Welcome to EDU Aero classes. In this tutorial, we will discuss continuity, that is continuity at a point, and what is continuous function, everywhere continuous function. First begin with continuity at a point. A function fx is said to be continuous at a point x is equal to a of its domain if and only if limit x tends to a fx is equal to f. That is limit x tends to a fx is equal to fa, which implies that limit x tends to a fx is equal to limit x tends to a fx is equal to fa. It means that right hand limit should be equal to left hand limit is equal to f of a, the value of function at a. Let us see this concept through an example. In this question, it is given that there is a function fx which is equal to x square, and we have to check whether it is continuous at x is equal to 0. Here x is 0. Now first we will find out the left hand limit, that is left hand limit at x is equal to 0 is equivalent to limit x tends to 0 negative f of x is equal to limit s tends to 0 f of 0 minus h, which is equal to limit x tends to 0 f of minus h, which is equal to limit s tends to 0 minus h whole square, which is equivalent to limit s tends to 0 h square is equal to 0. Now we will find out the right hand limit at x is equal to 0. RHL at x is equal to 0 is equal to limit x tends to 0 positive, that is of fx, is equal to limit h tends to 0 f of 0 plus h is equal to limit x tends to 0 f of h is equal to limit f tends to 0 h का whole square is equal to limit f tends to 0 h square, which is equivalent to 0. As we can see that left hand limit is equal to right hand limit. Now at x is equal to 0. Now we have to find out f of a, that is f of 0, which is equal to 0 का whole square, which is equal to 0. From above fact, that is this and this and this, we can observe that left hand limit is equal to right hand limit at x is equal to 0 and is equal to f of 0. Hence, this function is continuous at x is equal to 0. Next we come to continuous function. A function fx is said to be continuous if it is continuous at each point of its domain. That is, not at a single point, but at each point of its domain, the function should be continuous. That each domain should satisfy this condition. Limit x tends to a, fx should be equal to f of a. If a is a set of its domain. Here we see it through an example. Here in this example, we have to prove that a constant function which is given by fx is equal to k, where x belongs to R, a set of real numbers, is continuous at all points in R. So first we assume that let C be any real number. So First we have to satisfy first condition, that is limit x tends to c positive is equal to limit x tends to c negative is equal to f of c. First we will find limit x tends to c positive of fx, which is equal to limit x tends to c positive is equal to k, which is equal to k. If we apply a limit on a constant, it is equal to constant itself. So similarly, if we find x tends to c negative of fx, it will come out c negative on k, that is some constant. It will also come out to be constant. Now, if we have now we have to find f of c. It will come out, that is f of c is equal to k, is equal to k. So from first, second and third, we conclude that limit x tends to c, fx is equal to f of x, f of c. So above function is continuous at all points in R. Next we come to everywhere continuous function. A function fx is said to be everywhere continuous function if it is continuous on the entire real line, including minus infinity to infinity. That is, as we know that our number line starts from minus infinity, 0 to infinity. So a function fx is said to be everywhere continuous function if it is continuous on each and every point on the number line, such as this point, this point, this point, this point, in between this and this.